I'm Chingyue and I would like to introduce what is engineering drawing. Engineering drawing is a 2D representation of 3D object that convey key information such as shape, size, surface quality, material, and manufacturing process. The two keywords in engineering drawings are graphic language and also word language. Graphic language is to describe a shape, while the words language is a language to describe the size, locations, and specifications of the object. So before we start, we have to know about the drafting. Drafting is further divided into graphic language and also word language. Under the graphic language sections, we have line type. We have to know when we have to apply continuous line or dash line. The projection method, we have to know about the orthographic and isometric drawing method. And lastly, the geometric constructions. For the word language, we focus on the lettering, and the lettering is further divided into legibility and also uniformity. Legibility is all about the shape and also the space between the letters and words. For the uniformity, it's all about the size and also the line thickness.
In AutoCAD, alphabets and numbers are mainly used for clear communication in drawings, especially in dimensions, notes, and the title block. First, for dimensions, numbers are used to show the exact measurement of objects such as length, width, and diameter. This must be accurate and easy to read. Next, in notes, alphabets are used to provide additional information or instruction such as material type, surface finish, and special requirements. The text should be clear and consistent. Finally, in the title block, both alphabet and numbers are used to display important details like the drawing title, author name, date, scale, and drawing number. Next, we move on to the layout, which contains the title block. So the title block is usually positioned at the bottom of the drawing and follows a standard format. First, the organization or company name is placed clearly to show who produced the drawing. Second, the title of the drawing is included to describe what the drawing represents. Finally, the details of the drawer and the drawing are provided, such as the name of the person who prepared, the date, scale, and drawing number. This structured layout helps ensure all important information is organized and easy to identify. The purpose of engineering drawing is very important in design and manufacturing. First, it helps us to visualize mechanical components, allowing us to clearly see the shape and structure before it is produced. Second, it is used to communicate design intent clearly, so engineers, designers, and manufacturers can understand the idea without confusion. Third, the drawing provides accurate dimension for fabrication, ensure that each part is made with the correct size and specification. And finally, it helps to ensure compliance with industry standard, so the design meets required guidelines and maintain quality and safety.
My name is Aisha and I would like to talk about orthographic drawing. Orthographic drawing is a 2D representation of a 3D object showing distinct top, front, and side view. This is the reference that I use for orthographic and isometric drawing. This is for the front view. First, I would draw the object with desired length. First is 5, next is 1.5, 0.5, and lastly 0.5. I use the mirror command and select the desired component and then use the midpoint to mirror it. For the top view, I start with drawing the extension line. And I use offset with the length of 1. Then I also offset the bottom line for a length of 2.5. and I trim the rest. Next, I use the rectangle to estimate the point for both circles. This is how I draw the side view. First, draw the extension line. Then, draw one with 45-degree angle and connect the lines. Next, trim the unnecessary lines. For the bottom part, I just draw a rectangle and bring it using the middle point and then trim the bottom line. First, select isoplane left for front view. Draw the object with the given length. For the top view, change the orientation to isoplane top. Again, draw the object with the given length. Trim the extended line. Then I use the line to estimate the circle point. It is 1.25, 1.25, and 1.5. For the circle, type ellipse, select isocircle, and select the point, choose diameter, and enter the length, which is 0.75. Same goes to the other circle. Trim the other lines. For the right side, I use isoplane right. And just draw the object using the given length. And lastly, I trim the unimportant lines. Assembly drawings define relationships between product parts by showing how each part fits and works together. These are the types of assembly drawings and their applications. Exploded assembly drawing separates components to show assembly order, used in manuals and part catalogs. Outline assembly drawing shows only the exterior view and mounting dimensions, ideal for installation guides. Next is the sub-assembly drawing. Identifies specific groups of parts to simplify manufacturing processes. Schematic assembly drawing use symbols to show functional relationships essential for electrical or HVAC layouts. Detailed assembly drawing provides precise dimensions and tolerance for high precision components like gear assemblies. General assembly drawing show the finished product in its final position for production planning and inspection. Detailed drawing should consist this following information, which is engineer's name, part name, material type, drawing scale, date and revision, necessary views, front, left side, right side, top, bottom, and back, isometric view, and all necessary dimensions, width, depth, height, size, and all dimension tolerance. This is an example of detailed drawing. That's all from me, thank you.
Now I'm going to show you how to create a layers for the drawing that we designed. So you can see the layer properties on the ribbon or toolbar. So you click new layer and then write anything that you want, either text, hatch, dimension, depth point, center lines, and then you can change the color itself, the square one. And then since I already put text, so I deleted it and then close. And then you want to change the dimension, so you have to find it on the command. So put write D on the command input and then click enter dimensions. So you can see the modify, click modify, and then this is the place that you can adjust for the dimensions, the line, the symbol and errors, the fit options, the size, scales of the dimensions, and then the decimal points for the dimensions. So it depends on your preference. And then click close, and then you can click on the circle that you can do for the dimensions. Now I'm going to show you how to create the layers, the color of the layers. So you can see that just click the dimensions and then right click and then select similar. It will select the all the dimensions, and then you click the layers, then click the yellow colors for the dimensions. And then for the straight lines, select similar, and then you just click the layers hatch, so it will appear the green color one. And then for the text, then you click layer and then it will appear in blue color. And then for the center line, click back on the layers. For the center line, it will be in the red color.
Moving on to dimensioning standards. Dimension means giving the necessary size information on a drawing. Drawings should follow recognized standards such as ISO or ASME. These standards help make drawings clear, consistent, and acceptable in engineering practice. The main dimensions should be included are the length, width, height, diameter, or radius. These dimensions are essential because they define the actual geometry of the object, and without them, the drawing becomes incomplete and useless for fabrication. There are some basic rules of dimensioning. First, do not duplicate dimensions. So here, we have an example of an object in the layer white, and the dimensions are layered red. So each size should not be given more than once. So as you can see here, for all the dimensions here, they are only appearing once, and there are no duplicates. Repeating the same dimension in different places can cause confusion in the reader, and may cause errors if one value is changed while another is not. 2. Keep dimensions outside the object. So here we can see that all the dimensions, even for those in the middle of the object, are labeled outwards and stay outside the object. Dimensions should be placed outside the drawing so that the shape of the object remains clear and easy to read. Third is to maintain consistency, especially in the style, spacing, and method of the dimensioning. So as you can see here, we are using the same font type, font size, and alignment for the dimensions. So it makes the drawing look professional and easier to interpret. Next, we'll be moving to supporting dimensioning elements. So here we can see that these are dimension lines. They are used to indicate the measurement. And then the extension lines are the ones that are protruded outwards from the original dimension. So for example, this 11 will be the dimension line of 11 units, whereas this red solid line is the extension line, because we should not overlap it with the object. And third will be figures as symbol. So for example, this R10 will be radius of 10 units for this circle, represented by the arrow. There are notes that are needed when extra explanation should be required, but in this example, it is not shown. However, you can put in any sort of legend in the bottom, just in case you need to make things clearer. So, what are the methods of indicating dimensions? The first is the align method, where the dimension is written parallel to the dimension line and can be read from the bottom or right side from the drawing. Example would be this 22 or this R13. And there are the second type, the unidirectional method. So all dimensions are written so they can be read from the bottom of the drawing only. Both methods are acceptable and it depends on the standard or drawing practice, but one method should be applied consistently in the same drawing. So using this as an example, for mechanical equipment drawing requirements like pressure vessels, tanks, and piping, the drawing must include more than just the object shape. So in this case, you can see that the drawing has not just the white object, but the red dimensioning as well. So it must include the overall dimension, which shows the total size of the equipment, such as the full height, full length, or outer diameter, the wall thickness, if applicable. So in this case, you will have wall thickness represented by these 11 units. Material specification. So in a typical mechanical equipment drawing, which section is made of which material should be stated. For example, whether it is stainless steel or carbon steel, as this affects the corrosion resistance, cost, and the design of the equipment. Weld locations are something that would be common inside drawings as well, as they should be identified clearly, as since they will affect the fabrication quality. For example, pressurized vessels, pressurized tanks, they will require a higher quality of welds. So next we'll be moving on to nozzle size and position. These are the exact size and location must be shown to ensure correct installation. So an analogy here would be this hole here. So just in case there is a nozzle, this nozzle should be drawn properly and all its dimensions should be placed properly as well. So this will be placed in the center and the dimensions should represent it clearly. Finally, inside a general engineering drawing, tolerances should be mentioned as well. So in this case, it isn't mentioned, but along with the legends stated earlier, another legend for tolerances should be included. This is to allow variation in size to help control quality and function. So that will be all for the dimensioning standards part of the AutoCAD drawing.
Next, we're moving on to the demonstration part. For step 1, it is the setup. The first one is unit setup. At the command section, you can type units and then the unit pop-out will show like this. Here you can choose any unit you want, such as micrometer or inches or other desired units. Next is define drawing limits. At the command section, you can type limits and then you can define the lower left corner and also the upper right corner limits. So the last part for step 1 is layering. Same as goes as the before. At the command section, you can type layer or uppercase LA. And then the layering pop-up will show like this. So for the layering, you can add hidden center line and also dimension layering. You can adjust the color, the line type, and also the line weight. For step 2, which is the sketch geometry, for the first part is basic shape. In AutoCAD, we can draw basic shapes like lines and circles. It can be done just by clicking the elements in the green box. For the next part is object snaps or O-snap for the drawing accuracy. At the command section, you can type O-snap and then you can on or off the midpoint, the endpoint, and also the center or other things. In this video, I'll show you guys how to draw basic shapes such as line and circles just by clicking line and circles from the panel. In this video, I'll show you guys how to draw basic shapes such as line and circles just by clicking line and circles from the panel. In this video, I'll show you guys how to draw basic shapes such as line and circles just by clicking line and circles from the panel. In this video, I'll show you guys how to draw basic shapes such as line and circles just by clicking line and circles from the panel. In this video, I show you guys how to draw basic shapes such as line and circles just by clicking line and circles from the panel. In this video, I show you guys how to draw basic shapes such as line and circles just by clicking line and circles from. For step 3, which is modify geometry, the first part is trim and extend feature. For the trim feature, it can remove unwanted parts of a line or arc where they intersect with other objects. And for the extend feature, it can lengthen a line or object to meet another object. For the next part is add fillets or chamfer. Fillets can create a rounded corner between two intersecting lines. Meanwhile, chamfer can create an angle cut between two lines. In this video, I show you guys how to use fillet and also trim features. For the fillet features, you can choose the fillet icons or symbol from the panel. And then the comment section, which shows or asks you to enter a number of radius, and then you can connect between two intersecting lines to create a rounded corner. Same goes to the bottom. Apply the fillet features and then enter a number of radius, and then you can create a rounded corner between two intersecting lines. Next, for the trim feature, you can find the trim symbol from the panel, and then it just by clicking the trim symbol, and then you go to your drawing and you can trim or delete unwanted part that intersecting with other objects. In this video, I show you guys how to use fillet and also trim features. For the fillet features, you can choose the fillet icons or symbol from the panel. And then the comment section, which shows or asks you to enter a number of radius, and then you can connect between two intersecting lines to create a rounded corner. Same goes to the bottom.
So this is the slide where to show you where is the multi-line text icon when you want to use the first method. So on the ribbon tab, you go to the annotate tab, then you can directly see the multi-line text icon as circled by the number 2. So after you click the multi-line text icon, so how to use it is you click on any position beside the drawing that you want to put a label. Then you drag the cursor until a suitable text box size, and then you can type your label. And after confirm your label, then you click any space to enter and insert the labels on your drawing. So after you have already typed the label and you feel like you want to edit the text of the label, then you can by doing it by right click on the text, then you can see a list. Then from the list you go to the text edit. After you click on the text edit, then you highlight the text and then you can edit. You can edit like text, the size of the text label, the color, the size, and also the spacing. So this video shows how to put labels by using the two methods just now. So this video shows how to put labels by using the two methods just now. So this video shows how to put labels by using the two methods just now. So this video shows how to put labels by using the two methods just now. So this video shows how to put labels by using the two methods just now. So this video shows how to put labels by using the two methods just now. So this video shows how to put labels by using the two methods just now. So this video shows how to put. So the last step of your drawing is to finalize your drawing. So you need to add like a title box, the scale, and also plot for submission. So the title block, it must include at least the name, the section, the date, the activity, and also the space for marks. This title block, it must be the dimension of the A4 landscape size. Means that the dimension will be 297 times with 210 millimeter, or in inch, it will be 11.69 times with 8.26. And the drawings must be put inside the title block for submission. And then the scale, it will be 1:1. That will be shown in the video demo later. So the title block, you can manually redraw a new title block, or if you already have a template, then you can insert it from browse bar file by following the guide below here. So you go to the ribbon tab, and then you go to the insert tab, then you go to the insert, and then open up the drop down menu. And on the drop down menu, you click on the blocks from libraries as shown in the circle number 3. So after you have clicked on the block from libraries on the circle number 3 just now, then on your right side it should appear a dialog like this. And then on the dialog, you open up the drop down menu again as circled by the number 4. Then you go to the browse block libraries as circled by the number 5. Then from there, it will open up your file location, and you can insert the template that you want to put. So after you have included the title blocks, and you already finalize your drawings and put inside the title blocks, then next step will be creating a layout and plot for submission. So the guide here will show you how to do it. So firstly, you go to the bottom left below here. Then you go to a layout 1 or layout 2. So on the layout strip, then you type MV. MV means make a viewport in the command in layout strip as shown in the circle number 2. Then from the center of the layout strip appear, then you drag the cursor from the top corner to the bottom corner of the layout border as shown in the circle number 3. So after that, you double click on the layout sheet to activate the viewport. Then you go to the scale of the selected viewport as shown in the circle number 4 and choose scale to fit. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to use the block for submission. So this is the video to show you how to